Good evening, everybody. It is 9 o'clock and it's time for office hours. Welcome again. Thank you for giving up your time. It's been a long day. I had a Zoom meeting this morning at just after 6 a.m. and now it's 9 p.m. for my last Zoom meeting of the day. Obviously, Oracle and Zoom are joined very carefully, but yeah, man, a little bit over Zoom at the moment, but welcome along and we'll have lots of fun today. This is, in fact, I'll have a slide on this shortly. We're getting way up there in the office hours count. And so I'm hopefully you're enjoying the content and hopefully we'll be, maybe doing some office hours in person at some stage soon, given the state of the world. But enough about that. Thank you for attending and let's share some slides and get into the content. One moment, let's bring up my screen. Okay, hopefully sing out if you can't. Let me bring up the chat line as well, I suppose. Sing out if you can't see me, sing out if you can't hear me, and you should be able to see some slides there as well. As I always say, getting in touch is easy. I tried to put all my stuff on linktree/Connor. Probably the easiest way to get in touch with me is probably via Twitter. My direct messages are always open. You can send me DMs and I will see them at some stage. I don't block them. I may not get a chance to respond to them, but I'll always do my best. But Facebook, YouTube, blog, etc., it's all there. I have to be gentle on the keyboard. I got a piece of feedback from my last office hours session, someone saying, that's very nice, but when I listen to it, all I hear is you smashing away on the enter key every time you advance a slide. So I'll try to be gentle tonight. For those who are new to this office hours, I always say do not adjust your set. The content appears at the bottom left such that when we turn this into a YouTube video, I will appear at the top right. Let's get into bits and pieces, what's coming up, what's been going on, and then we'll dive into the tech content. Once again, I feel duty-bound to promote my local Australian user group. We've got a set of webinars coming up, similar vein to office hours. Please go to that URL or just go to ausg.org.au and follow your nose. You'll be able to see a whole lot of webinars coming up. It gets fleshed out during the year and hopefully I'll be able to participate as well. Coming up very soon, I think just in a few weeks' time, we have the UK OEG April Tech Summit. I've submitted some papers for that, so hopefully I'll get to participate in that as well. But that's looking like being a wonderful event as well. Once again, virtual. This is one I'm definitely participating in. This one's coming up in May. This is the Great Lakes Oracle Conference. This is a cool one because this time they're doing it much more workshop format. Along the lines of, rather than being short session, there'll be a number of workshops as well that you can sort of work along with as well. I can't remember what I'm doing. I think I'm doing one on successful application development. So that'll be a couple hour sessions as well. A little bit of promotion here. You're probably aware that about every month we run a Oracle Dev Live event. It goes for normally about I think half a day. The most recent one I think was on machine learning. There's been one on Java, etc. The very first one mid last year was on database technology. And I'm pleased to say we are cycling back through again. So database coming up, I think in May. So keep your eyes out for that one. That'll be, once again, more of a interactive kind of format. And if you've ever seen any of the Dev Live ones before, rather than being lengthy presentations, they're normally short and sharp, about 20-25 minutes, then Q&A. But this year, or this database one, we've added some stuff. At the end of each session, there will be a live lab workout. If you haven't seen live labs, just Google Oracle Live Labs. It's a great way of working through a set of exercises and learning material on our Oracle Cloud. Oh, I've lost my clicker. It would be remiss of me to say that yesterday we had a fairly major launch, a whole lot of extensions and improvements to our autonomous data warehouse. The data warehouse has been there for a couple of years now, but now we've extended a whole lot of features to make it much more accessible, much more usable for you. If you go to that link, you can watch the replay. It was done by Andy Mendelsohn yesterday. And that was why I picked the particular questions we're covering tonight. You'll notice when we get to it, there's a flavor of parallelism tonight, because that's the kind of things you'll often do in a data warehouse. Now you might be thinking, yeah, that's just marketing hype. You've got the data warehouse, what's changed? The thing I like about the thing that we've announced yesterday is if you go to this video, this is a great demo of the new data loading facilities, because what good is a data warehouse unless you can easily load data into it? We've always had loading from obviously over SQLnet or the object store, but these data loading wizards now, you can think of it as like the Apex data loading wizards, but on steroids. So you can simply grab spreadsheets, all sorts of JSON, etc., all sorts of file formats, and literally it's just drag drop to load them into the data warehouse with automatic column and table name discovery, etc. Very, very cool. So after the, hopefully jump on that YouTube link and you'll be able to see some very cool stuff that's come out of ADW. I will say this is the 488th, in fact, this will be the 489th office hours video, believe it or not. So we're close to that magical 500. Can you believe it? 500 webinars. You've never charged for any single one of them. Internally, we've actually crossed the 500 mark because a number of office hours sessions are given inside Oracle Corporation as well. You've heard the expression, eat your own dog food. We use the office hours platform internally as well as externally to customers and the general community. But we're close, 12 more office hours, and that will be a monumental achievement in my humble opinion. If you want to help us crack over 500 and well beyond, don't forget that you get to have a choice. If you want an office hours session just for you, just for your IT department, your developer team, etc., please reach out to us. Reach out to me or Chris Saxon or anyone else that's hosting office hours. We'll generally do our absolute best to see if we can do a session on topics that you want to talk about that are specific to your project, your success with the Oracle database. We really want to make you successful, and these things don't cost you anything. And finally, last bit of self-promotion. I've just released the next episode on my podcast. Just search for The Spoken Nerd, a pun on the spoken word. You can get to my podcast episodes. This one, believe it or not, the one I've just done is on internals of a block. I can tell you how much fun that was to try and convey how that all hangs together without any visuals or slides. But there'll be another episode coming out soon. Anyone that's a regular on the office hours knows that I've been putting this slide up for the last year regarding please stay safe, regarding COVID, etc. I think it's almost time to revisit this slide. I think we can almost change it to this now. The world is getting vaccinated. I think we've seen the light at the end of the tunnel. So I used to say, stay safe, communities look after each other. Now I'm more confident saying communities will be back. Let's get all ourselves vaccinated. I'm not trying to launch into a political discussion here, but let's just make ourselves healthy, make ourselves available to travel again and to meet and just to shake each other's hand or give each other a hug at conferences. I'm looking forward to that day again, hopefully soon. If you didn't see the tweet, this is what we're talking about. As I alluded to, a bit of a warehouse feel tonight because of our warehouse announcement yesterday. So we're going to talk about the Parallel DML hint, a little bit on ASH timestamps. Active session history is what ASH stands for if you're not familiar with it. Extents and data files, index compression, some interesting questions about index compression, SQL Monitor and its usage of bind variables. SQL monitoring is a very, very cool facility if you haven't seen it, and we'll do a little demo. And this final one, once again, finishing off with parallelism and its parallel versus indexes, which is better, does one impact the other, etc. 6 topics to get through, 8 minutes gone already. I'll do my best to see. Some of these are fairly short, so I'm hoping, I'm confident, I'm quietly confident we can get through all 6 tonight. As I said, sing out on the chat line if you have any questions. I've got the camera and the microphone, the screen a bit apart tonight, so I might have to keep bouncing back and forth to check the chat line, but we'll do our best to keep an eye on all your comments, etc. Let's get straight into it. The enable parallel DML hint. This is the question that came in. I saw a new hint in the documentation, enable parallel DML. Can we use this instead of the old mechanism of having to set it for the entire session? If you've not seen Parallel DML before, up until, I think, release 18C, if you wanted to actually do DML, and when we say DML, although DML officially includes select, the DML in this context, we're really talking about insert, update, delete. If you want to do those in parallel, you had to enable a session flag. You would do alter session enable parallel DML, and then you were able to do it. This is a new hint that's come in the documentation that suggests you might not need to. Let's explore. So the question is, can you use this hint? Let me put on my diplomatic hat and say yes and no. Yes, you can use the hint. No, you might not want to use it. And I thought we'd explore why I'm giving such a vague answer. So, first demo for the night. Let's get stuck into it. Parallel DML. Must be light on the keyboard. To set the scene, what we're going to do is we're going to have a table called stage, which is our staging area. That's going to be used to load data into something. And we have a table called T, which is a very simple copy of stage. We're going to simply go from stage into T. They're both just copies of all objects, which obviously is not a huge view. It's about 80,000 rows, I think. But what we're going to do is assume it's large, and therefore we want to enact some parallel operations to make the whole process more efficient. This is what we've had to do in the past. We will do alter session enable parallel DML to let the database know that inside this session now, we're going to allow parallel insert, update, or delete. You don't need this for a select statement. Let's do an explain plan for this is the kind of things we would do. If we're doing a big bulk load of millions or billions of rows, we would typically do a direct mode insert, which means insert append, and we would say, I wanted to do it in parallel to leverage all the power of the number of CPUs our server or our cloud instance might have. This is what the explain plan looks like. And you start to see these parallel kind of operations in the execution plan. Lots of things starting with PX and hybrids and round robins, etc. The whole intricacies of the parallel execution plan is maybe for another office hours session, but you can see that it doesn't look like your normal execution plan. The key thing is there, it actually gives you some feedback as to how much parallelism we're going to use. It says, I used a computed degree of parallelism of 2. That's probably fair enough. I'm running this on a laptop, so it's probably looked at my CPUs and gone, you don't have a whole lot of cores floating around there, so I've computed 2. Keep that in mind. Let's continue on. Let's explore the use of this hint now. So we're not going to have the session flag set. We'll turn off Parallel DML for this session. So now we're just a normal session. Any kind of attempt to do Parallel DML would normally simply be ignored. But this is the new hint if you haven't seen it before. There wasn't much fanfare made about it at all. I can do explain plan 4, insert, and there's this hint, enable Parallel DML. So rather than being at the entire session level, it's just for the scope of this statement, a little bit more granular control. And as we can see, that explain plan says, yep, I'm going to do the same thing. It looks exactly the same as if I was doing alter session enable Parallel DML. The computer degree was 2, and you can see those kind of things in the execution plan, PX coordinator, parallel combined with parent, etc., etc., etc. So far, so good. It's looking pretty good. Let's actually run it now, because just because the execution plan says it's going to do Parallel DML, I'm a natural cynic. I never believe it until I actually see proof on the box. So I'm actually going to run this now, which I've done. It's loaded up 75,000 rows. If it has genuinely done a parallel operation, it will have locked that entire table and prohibited further operations. If I try to do it again, I get the expected error message. It says, I've made a direct mode modification to this table. You have to commit or roll back before you can do anything else. So this error gives me confidence. It says the first one was indeed done as a direct mode insert in parallel. So I'm pleased with that. We'll commit that away. Let's flush out the shared pool so there's no evidence that SQL have ever been run. Here's where the yes and no comes into it. Let's now run those same commands again. So I've put a special hint in here called look for me, just so it's actually easy to find this SQL statement in the shared pool later. I do a Parallel DML, enable Parallel DML, insert append, and I commit those 75,000 rows. Worked fine. I run it again. So I might be getting from a different table, some other source, etc. Off we go again. That's another version. In we go. I've run it 3 times. So far, everything's looking fine. We're doing direct mode insert as we've proved before. It's all running. We're committing. That's fine. Let's have a look at VLOSQL. This is, I would suspect it's probably a bug, but it's certainly anomalous behavior. Even though it was an identical statement every single time, it appears that every time you use the enable Parallel DML hint, you get a brand new child version of your cursor. So you can see the SQL ID is unchanged. I ran it 3 times and I got 3 children. I didn't do it in the demo, but I've been through this. If I run it 10 times, I get 10 children, 20 times 20 children, etc. Every single time I get a brand new child. This is probably not a drama for you. And I say probably because how often do you run parallel operations? It's unlikely that you would take a statement like this and run it 1,000 times because high version counts for a single cursor can cause dramas in your shared pool. So yes, it's creating a new child. I don't think it's by intention. I think it actually is a bug. But even so, it's something you should be aware of. You don't see this if you just do alter session enable parallel DML. You only see it with the enable parallel DML hint. But as I said, unless you're planning on running that same statement tens, 20s, thousands of times, it's probably not a drama, but you need to be aware that you are going to get those child versions for every single execution. Let's go back to the normal situation where we just enable parallel DML. This time I'm going to do it with no hint. I've simply said, I'm not doing a hint. I've said, turn on parallel DML and just do an insert append. This is just a bit of extra information that I think is going to be useful while you're doing parallel DML. Notice that it's not enough if the tables aren't explicitly marked as parallel just to say enable parallel DML at the session level and let the database do it. It won't do it by default. If the tables themselves have been marked with a degree of parallelism, then yes. But if they're not, just simply doing a insert append won't activate parallel DML, even though you've said it's possible at session level. I actually have to have the parallel hint in there. Once again, about that parallel computer parallelism of 2. So that's just a thing to remember. When you turn on parallel DML at the session level, if your tables explicitly aren't marked as parallel, you'll still need the parallel hint in there. One thing you can do to bypass that is say, I want to force parallel DML at the session level, not just enable it. This is force it, which means whenever I see DML, I want to force that parallel DML. This is the kind of behavior you'll see if you're using some of the higher performing services in the autonomous database. If you're using the medium or high services, we explicitly force parallel DML for this reason, to get you access to a greater slice of the server pie. I do insert exactly append parallel. I've got force DML. The reason I wanted to put this example in there is I get parallelism of 2, just like before. I did insert append parallel, parallelism of 2. Let's now, I got force parallel, let's try that sentence again. Let's try now, I've taken out the parallel hint and said, I just want to do an insert append. But remember, force parallel DML is activated for this session. Look what I get in terms of parallel degree. If I don't have the parallel hint, I'm using a different parallel computation path. You've probably seen there's a numerous number of parameters in your init.org file that are prefixed with parallel in terms of the max number of servers, min servers, what kind of automatic optimizations we do, what kind of adaptions we make based on the CPU count, etc. So we're manipulating a slightly different execution path there. So if you don't have the parallel hint and you have force parallel DML on, you actually get a parallel degree of 12, which actually is, I think, the CPU count on this laptop. It's 2 cores, I think, or 2 by 6, 6 cores hyper-threaded. So it thinks we got 12 cores. So it's pretty much going to grab them all if it can. So that's just a thing to be aware of, is there are these subtle differences when you start manipulating parallel DML at the session level and you mix and match that with parallel hints. I just want to throw that in at the end there because you might get some interesting surprises. So hopefully that explains the yes and no, which is it's probably fine in most cases to not bother with flicking your session into parallel DML mode and just using the hint, because the likelihood of you running the same SQL thousands of times, I would imagine, is pretty low. If you are, then maybe that hint is not for you because you are going to start racking up those child cursors. But the other caveat there is that last demo I gave, which is force DML, force parallel DML, might give you a lot more parallel slaves than you think if you're just letting the parallel decision making go to the database itself. Counterintuitively, if you add the parallel hint, then yes, we actually may dial back the number of CPUs that actually get involved. So just be aware, as always, look at your execution plan because it's going to tell you what the computed degree of parallelism is. One thing I will note though is that does not necessarily mean you'll always get that level of parallelism when you finally come to execute it, because the database makes intelligent decisions as to what other parallel operations are going on at the same time. You might not be able to acquire all the relevant slaves that the execution plan said you were going to apply or acquire. So I hope that explains. Enable Parallel DML. In the main, a good hint to look at using. 9:20, we're all on schedule. Oh, we have a question come in, Q&A. When there are different degrees of parallelism defined on table and index or petition level, then what DOP will be picked? Okay, good question. Typically, it's going to depend on the execution plan. And funnily enough, we're actually going to see some different parallel execution plans in a later topic. So I might defer you till then. But for example, just very briefly, you might say, I want to select parallel, and the table is defined as parallel 8. But the execution man might decide to scan the index. If the index is planned with a different execution parallel degree, then it might toggle in that way. So it will typically pick one of the two. But if you have a big mix and match, it's really going to depend on the plan. If your plan is scanning just one petition, it'll probably use the parallel defined on the petition. If it's scanning multiple petitions, it'll probably use the parallel defined on the table. Auto DOP can pretty much pick whatever it wants. It's not limited to just the decisions as what's on the table, because it looks at other things as to what's going on, what your parallel max servers is, min servers, etc., etc. Okay, next one. Timestamps in ASH. Here's the question that came in. We capture active session history data for our AWR reports. Anyone that's licensed for AWR knows that ASH and AWR are pretty much the go-to when it comes to tuning your database and finding performance problems. It's just a fantastic facility. However, we often see erroneous sample times in our ASH snapshots. For example, an AWR report for snapshots between 9 and 10 a.m., 10 a.m. and 11 a.m., we will see sample times that don't fall in that time frame. What's going on? In this case, the person said sometimes even hours or days before. Is this a bug? Is this a problem? It's not a bug, and I'll try to be generous here. It's not a bug in our code here at Oracle. It could possibly be a bug in your code. And let me explain what I mean by a bug in your code. The way ASH works, or the concept of grabbing snapshots in ASH works, is active session history, as you probably know, gathers samples every single second of what's going on in your system. The term active session means every session that's currently active, either on CPU or waiting, essentially in the middle of some sort of call, is grabbed every single second. When it comes to taking an AWR snapshot, say every hour, every 15 minutes, etc., one of the things we grab is what's floating around in ASH at the time. So if our snapshot is to scan this period between 10 a.m. and 11 a.m., you would expect it's going to pick up activity only between 10 and 11. And in the main, that's what happens. If I have a number of SQL statements that commenced between after 10 o'clock and finished before 11, I've sort of pictorially described them there. There's 4 that have come, finished, started and gone. They'll all be collected in the snapshot, assuming they ran for 1 second or more, or just happened to get lucky and they were caught in those 1 second samples when we do ASH. However, if something started hours ago or days ago, but it finishes inside that snapshot range, then yes, we'll also capture that we will also capture that as well. That information also will be grabbed inside the snapshot. And this is a good thing, because the information we get at the end when a SQL statement has finally finished, we normally augment the ASH active session history information with additional data because we know that it's finally finished. We can actually update some of the instrumentation or the details inside ASH that occur once the statement is finished. So it's important to pick up that information because it was not present earlier. We can actually demo that. We're going to try to do it with a couple of sessions and see if we can show that in action. So I'm going to connect to Scott, and we're going to have a look at what's going on in Ash, and Scott's going to run a long query that's going to span an Ash snapshot. Ash snapshot is going to, I'm going to struggle with Ash snapshot. Oh dear. I've set my date format to be long so I can see the minutes and seconds as well, because we're going to be doing, I don't want to have you waiting for an hour while we take an Ash snapshot. Scott's user ID is 195. Remember that, such that we only have to look at information in active session history and our snapshots for one session for user ID 195. Sysdate from Jill says it's currently 21:25 in Perth, 25 past 9. So what I'm going to do is, this session is about to start running a long SQL statement. And what will happen is, while it's running, I'll take a snapshot. And then after it finishes, I'll take another snapshot. So it will have finished between the boundary of two snapshots. So it says get session 2 ready. That's my little mental note to tell me to get session 2 ready. Got a couple of different colors. So let me think. Follow my instructions here while session 1 is running. Okay, so we go back to session 1. Oh, hold on a second. Sorry. Oh, okay. Yes, that's right. Oh, do I create snapshot first or not? Oh, I've forgotten now. I can't remember which one I meant to press enter on. Okay, I think it's this one. Okay, now wait for session 1 to finish. Oh, I think I've made a mess of this one. I think I should have pressed enter here first. We'll see how we go. We may have to repeat this demo. So what this is doing a count of all objects 50 times. So it's going to run for about 20-25 seconds. That was the intent, such that we had plenty of time. Yeah, I run these in the wrong way. Deary, deary. But we'll see what happens in any event. Yeah, okay, let's kill this one off because it's not going to work. Okay, let's try again. Okay, so this says when we press enter, we're going to start running a long SQL, get session 2 ready. Okay, so we start this one running. It's 21:27:43, and now we take a snapshot. And that one started at 21:27:47. Now we wait for session 1 to finish. So this session has already been running in SQL, and then we took a snapshot here. The SQL will finish, and then we'll take a final snapshot. So it was running before we took the first snapshot, and we'll finish between them, which is what I was describing in the slides, and couldn't get my enter presses correct here. So there we go. We took a snapshot while it was running, and now we actually have effectively a final snapshot. Let's have a look at the interval time for this last snapshot. It started at 9:27:47 and finished at 9:28:13. However, when I actually go look at what's actually in there, I see some sample times that are before the actual beginning of the snapshot. This sample time is 9:27:43, which is before I even took that snapshot. That's just a simple proof of the slide I gave you. This SQL statement here commenced before either of those, that first snapshot, but even so it commenced before, because it finished inside the snapshot range, it was picked up by those details. Let's go back to the slides. Bear with me, my poor hound wants to get outside. Back in a second. See? There you go. There we go. A little bit of a departure there. Why, my poor dog. It's always about 9:30. He wants to go outside, but better he pee outside than pee inside. Back to the slides. Hopefully the first demo we can trash, but the second demo describe what we have here. SQL statement is already running when we take a snapshot. When we take a second snapshot, anything that finished between the two snapshots will actually be captured in that snapshot. So you'll see sample times well before that of the snapshot time. As I said before, this is a good thing. The final information that we have inside an active session history for a running SQL ID is actually augmented. We have things like total time waited, etc. It's useful information to have. If you want a really, really good set of slides on this, hello dog, a really good set of slides on active session history, that link there in the bottom, which you'll see when this becomes a YouTube video, John Bereznovich, one of the architects of Ash, he's back at Oracle and he's published some of his slides. This one's from 2014, but still a fantastic piece of content on how Ash works. In particular, the bullet point I wanted to stress there is if you're using Ash, please be aware that Ash is about counting, not summing. What do I mean by that? One of the things that I see everywhere when people are showing me, Ask Tom questions or ask me performance tuning questions about Ash is they say, I summed up the time weighted column, because we all know that the weight interface is very, very important. I summed up the time weighted column, or I took the average of the time weighted column. You can't do that. Active session history is about sampling of rows every single session. It's not the data inside the row that really matters that much. It's the number of rows. If you have 10 rows for a SQL statement, it means it was running for 10 seconds. I'll caveat that with the column called the SQL exec ID, but that's for another office hours session perhaps. In fact, we should do a whole office hours session on Ash if we can. But be aware that just looking at the columns in isolation, it's not similar to other metrics. We're actually looking at the number of rows. That's the critical numbers that matters here, the count of rows, not the data inside each row. In particular, if you look at the time weighted column, it typically will be 0 for most rows, and the final row will have a total time weighted. And because of that, it's not something you can take the average of, etc. You'll get nonsense results. Always think about counting rows when it comes to Ash to get the idea of how long things are running for, because each row is a second in terms of elapsed time. Number 3, extents and data files. 9:30, we're doing okay. Can we have John here? Yeah, I'm going to speak to John. JB's a good friend. Let me speak to John. We'll see if we can coax him into doing an Ash session. Because yeah, Ash is just mind-bogglingly good. Number 3, extents and data files. Very simple question, this one. If a table space has more than one data file, how does the database decide which data file to use to put the next extent in as objects grow? And I'm pleased to say we use a very simple thing called the KISS principle. Keep it simple. And that is we simply round robin them. And rather than just simply say that, let's do a very simple demo because this is a nice, easy one to answer. Even with the sound of panting here at my side. I'm going to create a table space called demo. It's 50 megabytes in size, and I'll add a second data file to it. So there's 2 data files, each of 50 megabytes in my demo table space. I'm going to create a simple table here, and you can see I've got a column there which is char 1000, which means it's going to be a very wide rows. It'll consume space very, very quickly. So let's do a very simple, for I in 1 to 20,000, let's insert 20,000 rows, just smashing away and commit that. I saw something pop up in the chat. Cute pup. He's a cute pup. This is Bailey, my rescue greyhound. Let's have a look what happens after I put 20,000 rows, each of 1,000 bytes, so it's about 20 megabytes, into my table space called demo, which has 2 50 megabyte data files. And we can see what's going on. The first extent number 0, went into file number 194. We don't really have to worry about what file number 194 is because there's only 2 in the table space called demo. And it was 2 megabytes in size. 195 was the next file. That was extent number 1. The next one went back to 194. You can see we went 194, 195, 194, 195. We simply flipped-flopped back and forth, each time taking a 2 megabyte extent. Now, the reason I should have elaborated carefully. Let me kill this demo. Run it again. Let me kill it one more time because I need to make a valid point. Okay. I've created this table space called demo, and I've explicitly said it is locally managed with a uniform size of 2 megabytes. I should have made that clear in the first. So every extent will be 2 megabytes in size. Now I add another data file, which is also 50 megabytes. I create my table with 1,000 byte rows and put 20,000 of those 1,000 byte rows in. being about 20 megabytes in size. Because I can only allocate extents in 2 megabyte chunks, the first 2 megabytes came out of file 198. The second extent came out of file 199, the first third one out of 198, and we simply flip-flopped round robin style back and forth. If there were 3 data files, you'll see it go data file 1, 2, 3, 1, 2, 3, etc. It's a very simple round robin exercise. That way we have a fairly even distribution. Quick question. Is there any performance impact in using small file table space to big file table space? No. Is it fine to keep everything on a big file table space? Yes. Do you have anything to consider while trying to decide the type? Generally not. Big file table spaces are fine. We use them extensively on Autonomous. It's not really about the table space that matters. What really matters is your underlying storage. If you've got one single hard drive, like my poor laptop, it doesn't matter how many data files and what structure they have, you are limited to the performance of that disk, obviously. Obviously, on a genuine production server, you're probably running ASM or some other kind of volume management, and therefore what's going to happen is you'll have tens, hundreds, thousands of disks making up those big, large volumes. And really, as long as you have a sensible striping structure across all of them, which almost all volume managers will do nowadays, ASM will do the same, stripe and mirror everything, then yeah, you're going to be spreading out that load irrespective of how you basically manufacture your table spaces. The decisions between small file and big file generally come down to more in terms of your backup regime. If you've got a single big file table space, which is hundreds of terabytes in size, be aware that that is effectively almost your single unit of failure. You might have to restore the entire lot of it if you have a corruption, etc. I think there's been some recent advancements where we can restore parts of a big file, but generally be aware that if you put all your eggs in one basket, so to speak, a small corruption which requires a data recovery might require a big outage. Is it good practice to always use uniform extents or only for certain scenarios? Funnily enough, that's just for the first part of this demo. For me, I always use the system allocated extents. I never use uniform extent sizes anymore. It's more of a hangover from a bygone era when we were still trying to convince people to not choose specific extent sizes for every single object. So let's continue the demo and you'll see one without uniform extent sizes, I think. Let's drop that table space now and recreate it now with a little bit of a tweak on this demo. The first file is only 8 megabytes in size, and the second file is 50 megabytes. So how does that affect the round robin policy? Well, it doesn't, except when common sense comes in. I create my table, smack in another 20 megabytes, and as you would expect, what goes on is the first 2 megabytes goes in file number 200, the next in file number 2, the next one in file 200, the next one in file number 2, the fifth one in file number 200, at which point I've pretty much run out of space in file 200, and therefore we simply go file 2 all the way along. So that's the 8 megabyte file and the 50 megabyte file. We'll round robin between the two until the 8 megabyte file can't fit any more extents, and then we'll simply move to the one that does have the free space. If there were several with free space, we would round robin just between them. Let's drop it again. And let's now create one with just a 50 megabyte extent. And I just wanted to put these last couple of bits in the demo in there such that we could see what happens when we don't have a uniform extent size. You can see I've just used what we recommend as the default. Simply give it a data file, let the database sort everything else out. We have what's called the system allocated extent sizes. I'll add another data file as well. So we got two 50 megabyte data files. Once again, 20,000 rows of 1,000 bytes each. This is what we see. As most people are aware, with a system allocation, you start off with 64 kilobyte extents until you have 16 of them, and then we move on to larger extents. But this is quite cool. We've done this pretty intelligently. Notice for those 16 first extents that are only 64K in size, we actually used the same data file. We didn't round robin. The reason for that is we're hoping, and in this case we did because it's a brand new table space, we're hoping to get contiguous data. Most disk operations coming from the database can read at most in a single trip to the disk farm 1 megabyte. That's how we do full table scans. We try to retrieve 1 megabyte at a time. With these 64 kilobyte extent sizes, a multi-block read will never cross-span an extent. However, a storage infrastructure will normally notice that you're doing repeated queries for contiguous space and do some prefetching for you. So for the first 16 extents, we're going to keep them all in the same file to try keep them to a contiguous megabyte. Hopefully, the underlying storage infrastructure will then be able to take advantage of that. Once our extent sizes jump up to a megabyte, then we're back to round robin again. File 10, file 9, file 10, file 9, because we're now at 1 megabyte. If I kept going, eventually we would jump to 8 megabytes and we would continue to flip-flop between the two. So hopefully that answers your question about using uniform extents. For me, I pretty much just use system allocation now and just let the database look after it. It's rarely going to be a problem. If I have an object which is say 1 megabyte, is it really going to make much difference whether I do a multi-block read of 64K 1 megabyte? Unlikely, because if it's that small, it'll be sitting in cache most of the time anyway. If it's massively big, then this overhead of just these first few extents is going to be tiny compared to reading the rest of the object anyway. There are some niche caches. I'm struggling with my issues, my ashes and my snapshots and my niches and my caches. There are some niche cases. That is partitioning. If you create a partition table, in most versions of Oracle, we will skip 64K extents and 1 megabyte extents. We'll simply grab 8 megabyte extents at a time because we think partitioning, why would you partition something? Because it's going to be big. So on most systems, you'll see partitioning immediately jump to larger extents, but we'll still round robin them between available data files. And obviously big files means there's only one data file, so you won't be doing any round robining, but the extent allocation policy still applies. One thing you will see in the documentation that I wanted to cover off here for a somewhat negative reason is if you search the Oracle docs, you'll see in various places in the ASM guide a thing called intelligent data placement. And that is, if you have a disk drive, which these things will probably be legacy very soon, you probably won't see disk drives anymore soon, the way SSDs are growing in size and reducing in price. Disk drives, rotating heads back in the old days, which we still have in most of our servers, have this issue, this thing called zone bit recording, which means a piece of data is the same size no matter where it is on disk. So what that means is, because the disk is like a turntable, the amount of data you can fit in the same arc of a disk near the middle of the disk is less than what you can fit on the outside. Obviously, the disk spins at continuous speed or at constant speed. So you can read this much data on the outside at the same speed as you can read this much, much less data on the inside. Because of this, dinosaurs like myself, when we used to explicitly place data on disks, used to be very careful to never make a disk more than, say, 50% full, because they fill from the outside in, and therefore the fastest part of the disk is on the very, very outside. In fact, the fastest is slightly in from there because we have to take into what we call head movement timing as well. But typically, about where that red ring is, if you could put all your data there on a disk, you got the best performance. Automatic storage management, ASM, Automatic Storage Management, had a facility where you could nominate, you say, I want my data to be placed in intelligent fashion. I only use that part of the disk and then bypass the rest. That sounds really, really cool. We introduced this facility in 11.2 and we deprecated it in 12.2. It's still there as a function, but I think we've realized the fact that generally now, the things that are going on disk platters, your archival data, your slower data, you don't care. The real gold standard nowadays is your flash, your persistent memory, your Optane, your NVMe. The future is flash. The future is non-rotational storage, which is why we've deprecated that function. So just be aware that even though I talk about, it doesn't really matter where it goes on disk, we still have these interesting facilities in ASM, but they will disappear in the same way that rotational disk, I think, is going to disappear. Spinning rust, as they call it. Index compression. Oh, question. Do we have any standard package for partition advisors? I see partition advisor in OEM, but it requires root user access, so I can't use it via OEM. I'll have to take that one offline. I didn't even know we had a partition advisor. All I knew is that I knew that coming in autonomous is we're having some autonomous partitioning coming in and autonomous in a future release where we'll try and make intelligent decisions about how to best partition things. But no, I don't have any experience with the partition advisor. I'll see what I can find out for you. Index compression. If you compress an index, how can you tell if the index data is being or has been compressed? Now, that seems a silly question. It seems a very like a cynic's question. It's like saying, if I drop the table, how do I know it's really gone? Or if I've inserted some rows, how do I know they're really there? It sounds like the kind of a nonsense question that someone would ask if they're just being skeptical about the database technology. It's not actually a silly question. It's actually a very good question to ask. And the best way to explain why it makes sense to ask this question is with a demo. So let's do another demonstration here. So we'll start simple. Here's a table called T. It's just 5 copies of DBA objects. I create an index on it. And if I look at what I've got, it says I have no compression at the moment because I didn't specify it. The compression is disabled. And it currently has 1,711 leaf blocks. If I rebuild it using advanced compress or compress advanced low, and then go run that same query, it says, yes, it is now compressed. And yes, the number of blocks has dropped by about half. This is that thing of think, well, it's sitting there right in the dictionary. Like, why would I need to ask the question of how do I know if it's compressed? I just look at the column. It says it's compressed and the leaf blocks has gone down. This is true for a index like this on a non-partitioned table. Let's drop that table and partition it. And here's where things get interesting. So once again, this is pretty much the same table, just a lot of copies of DBA object, but I've now partitioned it into 3 partitions. Let's create a local index on it, which means that index segment now exists for each partition. So I've got effectively 3 indexes on this table, 1 for each partition. By default, as you'd expect, compression is disabled. I didn't nominate it. There's no compression there. And we see the number of leaf blocks. I think partition 2 is the one you want to keep an eye on, 614 leaf blocks. I modify that partition to say it's compress advanced low. And here's the subtle difference when it comes to partition tables. I can modify a partition without actually changing a partition. Notice there, it was very instant, it was very quick, and there's no rebuild command in there. If I go look at the catalog, it says this partition P2 has compression of advanced low. But look at the leaf blocks. It still says 614. That's why this is a valid question. That partition is marked as, I want you to be compressed next time you rebuild it. But it's not compressed yet. That's why it's a good question to know. How can I tell if that 614 is pre or post compression? Now, obviously I can rebuild it to force the issue, but that's something I'd rather not do. But just to prove that rebuilding it will now take into account those facilities, you can see it's gone from 614 down to 327. But I want to know, obviously, is that 614 figure a pre or post compression without having to go through the effort of actually rebuilding it? So let's have a look at what we can do. What we can do is we can actually go get the object ID and data object ID for the various components. That's for the table, sorry, that's for the index itself, and that's for the individual partitions. We don't have a data object ID for the index itself because it's just a logical structure comprising the 3 underlying objects. This is what we can do. If we store the object ID for the index, we can actually use this undocumented function called sysop leaf block ID. And what that's doing is saying, for each given row in the table, tell me what the leaf block number is for this particular table. It's a way of saying, what leaf block in the index is this particular row stored in? If we query that, we can actually get all this information. We can see that each individual row, this one's in leaf block number 239, this one's in leaf block number 287, etc., etc. Oh, did I just hit once too often then? I think I might have. No, I didn't. Okay, here we go. What I've done is flip that output now to say, show me what the distribution of leaf blocks is. So the table now where it's not compressed says I have 62 occurrences where there are 239 rows in a leaf block. I have 34 occurrences where there are 287 rows in a leaf block, and 63 occurrences where there's 299. So looking at these two, on average, I've got somewhere between 240 and 290 rows in each leaf block. If I look at the average length of those columns that are in the index, the owner is 6 bytes, the object type is 5 bytes, the object ID is 10 bytes. I need to store a row ID in an index as well. So if I say 10 bytes for the extended row ID, plus the sum of these 3 column lengths, 6, 5, and 10 gives me 21. How many there will fit into a leaf block, which is 8,192 bytes in size? It says I should be able to get about 260 of those rows into a leaf block. That aligns with the data I saw before, somewhere between 240 and 290 rows per leaf block. So with the data as it is, uncompressed, this tells me that if I'm expecting 264 per block and I'm seeing that on the leaf blocks, it means the data is uncompressed. If I rebuild that in that partition compressed low, rerun my leaf block ID, now it says on average I'm getting about 477 rows on every single leaf block, or even slightly higher, about 485 rows on every leaf block. There is no way that my data, which is 11 bytes plus a 10 byte row ID, there is no way I could fit 400 of them on an 8K leaf block without some sort of compression being in place. So you can use the leaf block ID function to get a count of how many rows I'm getting per leaf block, and that's going to give you a very good indicator of whether the data is compressed or not. Now we can see that we've got effectively 2 partitions, one advanced low, etc. If you don't want to use undocumented functions, which is a totally good position to take, just keep an eye on the time. Yeah, I think we'll finish off. You can do this as well. You can simply do analyze index T, partition P3, which has not yet been compressed, validate structure. And it'll give you 2 columns in the index stats views, the number of compressed leaf blocks you have, the number of uncompressed leaf blocks you have. Now you might be thinking, well, why didn't you just show me this command at the start? Why did you give me this strange leaf block ID stuff? Because an analyze index validate structure locks the entire index and therefore effectively locks the table as well. It's not something you would generally do on a production system. If you had a read-only standby or a snapshot standby, it's a perfect candidate to run these kind of commands. But analyze index validate structure will lock the table, and therefore it's a lot more intrusive than using the sysop leaf block ID. If I now rebuild that index, that uncompressed one, compressed advanced low, and validate structure again, you can see I now have 463 compressed blocks and no uncompressed blocks. So if you do have a copy of your production database that you can do things like this on, then analyze index validate structure is obviously going to work as well. Just to prove, you might be thinking, well, there is an online facility for validate structure. Maybe that's a way of not creating any locking problems. It's true, but it doesn't populate index stats whenever you run it online. So that's why you can't use online analyze index validate structure. You don't get any data out of your index stats view. So just to reinforce, be careful if you're going down the analyze validate structure route. Don't just log onto your production database, please, and say, I saw it in Connor's talk. We'll do that because, yeah, you're going to lock the entire system and probably not be very popular. And also, the examples I used here, we're using advanced compress low, advanced compress high, etc. Anything with the word advanced in it means it's a separately licensed option. You don't have to use advanced index compression, but if you are licensed for it, or if you want to use advanced index compression, you need to have the advanced compression license. There is a facility there called basic compression, which is a no-brainer. That is, you can simply do create index on a composite key and nominate the number of leading columns to compress. In this case, I'm saying compress columns 1 and column 2. Basic compression on indexes simply looks for repeating values and stores them in a symbolic table in your leaf blocks. This is a no-brainer. If you have indexes that basically have composite keys, look at using compression. Even if you have a single column, but it has repeated keys, foreign key indexes are a classic example of that. Compression makes those indexes more densely packed. You get better utilization, less space, better memory management because more data fits in the buffer cache. Index compression basic doesn't cost you anything, and it's a no-brainer. You pretty much should have it on almost any index with repeated keys. If you want to know what you should do with basic compression, once again, analyze index validate structure will give you the optimal compression count, how many columns you should compress, and it'll also give you how much percentage you'll save as well. A little bit of chat. Index compression would perfect performance. Basic compression, no impact on performance. Advanced compression low, minimal. Advanced compression high, more, etc. It's like a sliding scale. SQL monitoring. Is this the last one? Maybe second last one. Anyway, we got 5 minutes. I think we can get this one done. We might go a touch over, but we'll see if we can get this one done because this one's an interesting one. Not that the others weren't, hopefully. Okay, our last one, SQL monitoring. This is not really a question. It's like this is a statement that came in on Ask Tom. SQL monitoring is corrupting the bind variable display on its report. Can you help me work out why? That seemed a fairly aggressive position to take, but rest assured it's not. Well, not almost, but there are some intricacies. Let's try again. It's getting late. There are some intricacies when it comes to SQL monitoring and bind variables, which of course we will do with a demo. Last demo. What do I call it? Yeah. Let's create a table as a copy of DBA objects. I've created another kind of, let's create a table, a copy of DBA objects. I've added a couple of other columns as well, just to pick up some additional data types, which will become relevant shortly. Flush out my shared pool so there's nothing in the library cache. Let's do a very simple query with a numeric bind variable. Simply select, I'm using the monitor hint here, which says, even though it's not running for 10 seconds, I want you to do SQL monitoring anyway, because that way we don't have to wait 10 seconds or you don't have to wait 10 seconds. And I'm using the bind variable N1. Oh, I might have pressed enter a lot of times then. So let me kill it. We'll go it again because I pressed enter too many times. Flush the shared pool, run that query. Oh no, I might have just missed some pauses. I went and found the SQL ID for that query, which was select monitor count less than B1. That's the SQL ID, and this is what comes out. And this is the text version of SQL Monitor. I might stretch that window, see if it'll make it fit a bit. There we go, looks a bit better. And one of the cool things with SQL monitoring is it actually spits out the bind variables. Even though the query just has a bind variable in it like that, it found the bind variable and actually put it in the SQL monitoring report. That's very cool. Flush out the shared pool. Let's try it now with a date. Same query, just this time I'm using a different column, the creator date, which is a date column, and a bind variable of a date. I find the SQL ID for that. That's the bit that we skipped past the other one because I missed out a pause. I pinned out my SQL Monitor report, and for a date, it gives me a perfectly formatted date as well. 2158 tells me I'm running out of time. Let's flush out the shared pool. Let's do a varchar2, XXX here. Go get the SQL ID, pump that into SQL Monitor report, and fantastic. It's all looking just fantastic. What is this person talking about? There's no corruption here. The binary variables look fine. Okay, let's do a timestamp, one of the newer data types. And when I say newer, I mean it came out in Oracle 9. So yes, it's only a decade old. There's my SQL ID. Let's do a SQL monitoring report on that SQL ID. And yes, there we have the timestamp there as well. Not so fast. Yes, we did grab the bind variable, but that doesn't look like a timestamp. In fact, it looks like just some hex. And this is where this question came from. The fact that when you use timestamps, SQL Monitor report gets a little confused. So the question is, how can we dig into this? Well, what is that? It's actually not too hard to actually digest. Even though SQL Monitor isn't going to give us the output we want, a little bit of work on our part, and we can get that information without too much effort. It's 22 characters long, which is really 11 hex pairs. And so I could actually split them out just using a bit of substring into our 11 rows of hex there. We can dig into these now to actually work out what the internal format of a timestamp is. It actually looks like this, a timestamp. Byte number 1 is the century plus 100. We hate zeros in the database because zeros often mean end of file, end of field, etc. So we generally steer clear of zeros. We add 100 to the year. The month is always non-zero, so just the byte 3 is the month, and the day, the hour plus 1, because the hour can be 0, the minute plus 1, and the last 4 bytes are the nanoseconds of a timestamp. So it's actually it's 11 bytes, that actually makes up a timestamp. So the first thing I need to do is convert these numbers to decimal. Here's a sample timestamp that I took earlier today, so we can actually compare it to here. I convert that string to decimal, and it looks like this. And as you can see, it's 2021 March 18th. This is 11337, so we add 1 to the 13 to get 14, so we don't want a 0. We add 1 to get 18, not 17, 49 from 48, and the last 4 bytes as hex is the nanoseconds, 456 nanoseconds. So we can dig into that hex and quite easily turn it into the bits and pieces of a timestamp. So I've written a little function, which I'll put on my GitHub repo, that simply takes that hex that comes in and does what you just saw there by simply padding it out, removing the hundreds, the excess hundreds, taking the ones away, etc., getting the nanoseconds, and we have our facility. So this function I'll make available to you. You simply pass in the hex string that you get from your SQL Monitor report, and you'll get the actual real timestamp out so you can see what the bind variable is. So hopefully that will solve that problem. I will log a bug against SQL Monitor as well, so that we don't have to do that work forever. One final thing I add is, what if we take a timestamp with a time zone? That's a different data type with extra information. I get the SQL ID, run it into my SQL Monitor report, and that's a bit sad. We don't get the bind variable captured at all, which is a bit sad. Now, that is not the fault of SQL Monitoring. SQL Monitoring actually digs into the catalog to find it. And if you look, for timestamps with time zones, it doesn't get caught in SQL bind capture, so we can't find it. It doesn't even get caught in the other XML element of BSQL plan, where normally everything gets dumped. If we go hunting through here, there's nothing about that bind variable. SQL Monitor just drills into these views to actually find its information, so that's why it can't show it, because it's not being captured. If you do want to capture the bind variable for a timestamp with a time zone, pretty much the only way you can do it is with a trace file. So there's my default trace file. I turn on session trace with binds equals true, run my query, disconnect so I can finish off the trace file. And if I bring it up in Notepad, let's put that so you can all see it. Do a find of the 18th of March, scroll off a bit. That's where you'll find. Somewhat interestingly, the trace file not only found the bind variable, it actually nicely formatted for us as well. So it went and did the extra work for us. So yeah, unfortunately, as far as I know, the only way you'll find a bind variable for a SQL, for a timestamp with time zone, is actually with SQL trace. I'm done. So last couple of notes on that topic. When in doubt, a trace file is going to show you all the binds. It's going to be the definitive performance analysis tool. But other than that, SQL Monitor is actually going to pick up all the binds. Timestamps are going to be a little bit convoluted, but that function will be available to you from my GitHub repo. And timestamp with time zone, once again, I'll log a bug with that as well. We're out of time. We got 5 out of 6 done, which is generally a pretty good effort for me. There's a few things in the Q&A. Let's have a look at that. Nope, they're all covered off as well. I think the chat's covered off as well. What is my GitHub repo link? Good question. Let me type up a notepad so I can share it on the screen as well. Put it right here for you. It's github.com/Connor_MCD. So that's my GitHub repo. Now, hopefully you can see that. I think that's right. But if not, just search for my name under GitHub and you'll find it there. I'll publish that probably in the next few days or so. Let's stop the share. Finish off. All I can do is apologize for going over time. That's my fault. I just get too much into the tech, too much talking, too much damn dog letting out the door. Damn hound, you're a pro. But thank you very much for your time as always. Obviously, it's easy for me to do these because I love talking tech. It's you that gives up your valuable time to participate. So I always am very, very grateful. This will be available on video soon. As always, stay safe, stay healthy. Please reach out to me on Twitter if you have any questions or comments or feedback. I always love hearing from you guys. Get vaccinated, and hopefully we'll see you all on either next month's office hours or soon, face-to-face with any luck. Thanks very much for your time, everyone, and bye for now.